Hello, today I'll be presenting the experiment of p-aminobenzoic acid to benzocaine by Fischer esterification by me, Benjamin Esquivel, and Alyssa Mitstarfer. It's performed on March 3rd, 2018. Here we have our abstract. I'll read it as follows. This experiment involves the conversion of p-aminobenzoic acid into benzocaine by acid-catalyzed Fischer esterification. The reaction involves the conversion of a carboxylic acid to an ester and the elimination of water. The reaction was catalyzed by sulfuric acid and heat in this reaction. The percent recovery of benzocaine was calculated to be 17.43%, a low yield. Despite the low yield, the experiment was a success because pure benzocaine was obtained, which was confirmed by IR spectrometry and melting point. The reaction that is performed in this experiment is shown here. Benzocaine, the common name for ethyl p-amino benzoate, is synthesized by Fischer esterification of p-amino benzoic acid. In this reaction, we use ethanol as the alcohol and sulfuric acid as the strong acid that catalyzes the reaction. Water is also a byproduct of this reaction. Without a strong catalyst, the carboxylic acid is otherwise unreactive with the addition of an alcohol. The mechanism for the reaction is shown here. First, an acid-base reaction occurs between the carboxylic acid and the acid, forming an oxygen cation, making the carboxylic acid more reactive. Next, the alcohol attacks the carbon atom, forming a tetrahedral intermediate. Water then extracts a proton from the alcohol, forming a carbonyl double bond. Simultaneously, water is extracted from the compound, forming the ester target product. Each step in the mechanism is at an equilibrium, so the reaction conditions in this experiment are favored toward forming the product. For instance, using an excess amount of alcohol shifts the equilibrium toward forming the product. Here is a representation of the aspect of Le Chatelier's principle we are incorporating in this experiment. Our goal is to shift the equilibrium in the direction of the products. Therefore, we are going to increase the concentration of ethanol, or the reactant. Conversely, if there's an increase in product, then the equilibrium would shift in the opposite direction, generating the reactants. One of the goals of this experiment is to remove water and neutralize the acid catalyst so that the reverse reaction does not occur. Some background information on benzocaine. It is used as a topical anesthetic and is commonly interchangeable with lidocaine, another common drug. The two are similar in their uses, but they do have some differences. The two are a part of different groups of anesthetics based on their structure. Lidocaine contains an amide functional group, while benzocaine contains an ester functional group. Clinically, lidocaine is more often given as a prescription, while benzocaine is commonly found as an over-the-counter drug. Despite these differences, studies have shown that the two drugs are equally effective in reducing pain. Shown here is the mechanism of action of a local anesthetic drug, such as benzocaine. In the example, it shows an amine group as the local anesthetic, so it could be lidocaine, but benzocaine has the same mechanism of action in the body. Under normal conditions, sodium channels would be open to allow sodium ions to pass, causing the action potential or pain stimulus to pass on to the spinal cord. A local anesthetic passes through the membrane and is protonated and binds to the sodium channel at its binding site. Once there, it inactivates the sodium channel, causing it to close and not allowing sodium ions to pass. This blocks the action potential at the site of binding and does not allow the pain stimulus to reach the spinal cord. The purpose of this experiment is to synthesize benzocaine using Fischer esterification. Now we will go into the experimental methods that were used in this experiment. For 0.2 grams of p-amino benzoic acid and 2 milliliters of ethanol were added to a conical vial containing a stir bar. The mixture was stirred until it dissolved, and then 2 milliliters of concentrated sulfuric acid was added in a dropwise fashion to the mixture. The reaction was heated under reflux, and the apparatus is shown here. The mixture was heated. This slide. The mixture was heated gently. Was not allowed to boil for about 20 minutes. Once homogeneous, the mixture was heated for another 30 minutes, and it was taken off the heating under reflux and allowed to cool to room temperature. Once at room temperature, 5 milliliters of water was added. Then sodium carbonate, 10% sodium carbonate was added to bring the pH of the mixture to 8, neutralizing the sulfuric acid in the mixture. Vacuum filtration was used to collect the crude product, and while still in the filter, the solid was rinsed with cold water and further dried using vacuum filtration. The crude product was transferred to an Erlenmeyer flask with 4 milliliters of water already in it and a stir bar. That mixture was heated on a hot plate, and 5 milliliters of methanol was slowly added to dissolve the solid. Once the solid was dissolved, it was taken off the hot plate and the mixture was allowed to cool to room temperature. Once at room temperature, the mixture was added to an ice bath for 50 minutes. After precipitating in the ice bath, the crystals were dried using vacuum filtration and washed with 5 milliliters of cold water. The mass melting point and IR were obtained from the product. Here we have our results and discussion of the synthesis of benzocaine. The melting point was found using Digimelt and was found to be 87.2 degrees Celsius. The mass was found to be 0.042 grams, and the percent recovery was calculated using equations 1 and 2 and was found to be 17.43%. Here you see the experimental IR benzocaine on top and the literature IR shown on the bottom. The experimental IR strongly suggests that almost pure benzocaine was obtained. Some notable peaks are the amine group shown by a peak around 33,000 right here, and an ester group shown in a peak around 1,700 right here and right here. Next, I will briefly discuss why some of the steps were taken in this experiment. The reaction was heated under reflux so that the acid catalyst would be activated and the reaction could proceed, but also to ensure ethanol or sulfuric acid would not evaporate out of the reaction. Sodium carbonate was added, and the mixture was made basic to neutralize the acid and prevent the reverse reaction from occurring. Vacuum filtration was used after precipitating the product into a solid and to remove any liquid that may be adhering to it. The cold water rinses were performed to remove any water-soluble impurities that were on the product. And lastly, the product was dissolved in methanol and reprecipitated as a last effort to remove any impurities. In the synthesis of benzocaine, we obtained a low percent recovery of 17.3%. Despite the low recovery, the melting point in IR spectrometry confirmed pure benzocaine was obtained. In this experiment, p-aminobenzoic acid was used to synthesize benzocaine by Fischer esterification.